Howdy, we are the Texas A&M Robomasters team. We are the only Robomasters competitor in the southwestern United States. Founded in 2018, we are a student-run robotics competition team consisting of more than 100 members from a variety of majors and backgrounds. Each year, we spend hundreds of hours designing, prototyping, and testing robots in anticipation of the Robomasters competition in Shenzhen, China. This competition pits some of the world's best university robotics teams against one another, all hoping to be crowned champion. Drawing over 6 million viewers each year, the Robomasters competition has grown to be one of the most popular robotics competitions in the world. In a typical match, 2 teams will each have 7 robots, and they will try to defeat the other team by shooting them with projectiles that lower the other robot's health. Our team consists of 3 main departments: hardware, software, and business. Our success is dependent on the synergy between all 3. Without hardware, there's no physical robot. Without software, there's no way to control the robot. And without business, there's no money or supplies to build the robot. There are a total of 5 different types of Robomaster robots. The aerial robot attacks from the air with an incredibly fast rate of fire and provides a bird's eye view of the entire battlefield. The standard robot launches 17mm projectiles and completes on-field tasks to activate boosts using computer vision. The hero robot deals the most damage, launching 42mm projectiles at their opponent. The sentry robot is a fully autonomous robot that defends the base with 2 17mm projectile cannons. And finally, the engineer robot delivers projectiles and resurrects teammates, acting in a supporting role. Due to the complexity and cost of all of these robots, the hardware team must take a true engineering design approach to their construction. The hardware team begins their process brainstorming and going through design selection processes before transitioning over to CAD modeling. A lot of the team's time is spent developing and designing these robots digitally. We utilize computer automated design as well as FEA analysis to create scale 3D models of our robots and test their viability. Doing this allows our team to ensure that our robots not only meet the specified requirements in the rules manuals, but also allows us to design and be innovative without being wasteful. Once we are done designing our robots and have completed the final design review, we begin to build the actual robots. We utilize various machines such as 3D printers, lathes, and mills, as well as water jet cutting. Through these methods, we are able to turn our digital designs into real-life functioning robots. It is quite amazing to see something go from the screen to the stage. Our software needs are met by our 2 separate software teams, embedded systems and computer vision. The embedded systems team handles direct motor control, such as driving, remote control, the flywheels to launch the balls, the feed motors, etc. They also do wire management. Due to COVID, this team works heavily with the hardware teams, testing their robots via Zoom remote control of computers. Our computer vision team has worked to develop and test a machine learning algorithm to allow our robots to identify enemy robots, ensure that they are on the enemy team, aim at their specific armor modules, track those modules, and fire with slight movement prediction to determine where the robot will be when the bullet arrives. The construction of our physical robots, as well as the hardware needed to implement the aforementioned computer vision and embedded system tasks, is quite expensive. We rely heavily on funds received from A&M, as well as sponsorships from local and nationwide companies. We allocate budgets to each team based on their requirements and design implementations. We spend approximately $8,000 each season. We spend about $2,000 on DJI equipment. About $5,000 of the remaining budget is divided amongst the separate robotic teams, allowing the team leads to spend money on raw materials and fabrication costs for the robot. The supply chain section of our business team manages the procurement of products needed for hardware and software teams. The coronavirus has definitely put a large kink in our supply chain. Most of our suppliers previously were based out of China, and we have had much difficulty getting parts during the pandemic. There have been long delays in shipping and even a denial or lack of parts altogether. Starting in March, we had to get creative in our ordering process to build our robots without this typical supply chain. We have shifted to a more domestic supply and have started reaching out to local suppliers for materials and fabrication as needed. We believe that Texas A&M Robomasters not only incorporates and showcases the engineering ingenuity present at Texas A&M, but also does a wonderful job showing the resilient spirit of Aggies as we have continued to work and progress during this time.